look like for you? It'll look like this. And the only thing that's important here for you is in the bottom right-hand corner is the ebook. So this will open up the electronic version of the book. And then, what was it, 1.3 was the first homework assignment. So I go to chapter 1. And right now I'm looking at the 1.1 exercises. I click on this. I can see 1.1, 1.2. Here's 1.3. There's the actual material from the book, but then there's the exercises at the end. And these are the problems that you need to do. Right? So you look off that schedule. It says do number blah, blah, blah. You do them right here. Or you look at them here, and you do them on paper, right? Or electronically. Questions? Okay, now once you have done your homework, right, go back to modules, you'll have to turn them in, all right? And here's where you'll click to turn them in. So imagine you've already done the homework, taken pictures, saved them as a file, right? You will then click here, and you will, oh, I need to look at this as a student. You'll say start assignment, and then you will upload right here. You will choose the file from your computer, and you will upload it. So see how it says handwritten homework 1.3 and 1.4? I want one file for both sections. So you've got to condense all that work together into one file. I don't want a file for 1.3 and for 1.4. And so you won't have to turn in as many that way. You go back to, hold on. Any questions on that? The due dates for these are set. On that schedule. So on the schedule, see, it shows what we're going to cover, right? We're going to cover 1.3 today. We're going to cover 1.4 on Thursday. When are things due? Well, when you go to the modules, it shows you the due date. So the first assignment, 1.3 and 1.4, is due August 30th. August 30th at 11:59. That's next Tuesday at 9 a.m.? I think that's, did I set it for 9 a.m.? Yes. Yeah, I think it's set for 9 a.m. So right before class, this is due, those two sections. Does that make sense? All right. There's other things over here, your grades, where you can see your grades. Also files. If you click on files, this is where you can find, I'm going to be using notes. I may be projecting notes over there or over here. The notes that I use for this class are all available to you. You just click here, and you can either print these out, or you can have them electronically on your laptop, open during class. It doesn't matter. But here they are. These are the chapters for the notes. Yes?
Can you navigate to the turning in portion submission section?
Yeah. Hold on. I'm going to go into student view. You mean the modules where you turn in?
Right.
Okay. Like this? You want me to go in here? Yes.
Everything pretty much is under modules for homework.
Yes, everything's under modules. So under modules, this is how you get to the book. And then these are all just when you submit everything.
Okay.
Yep. Or where you submit everything. Files. Okay, files here. The schedule, the course notes. Okay, so I'm going to open one of these just so you can see them. Chapter 1 is probably going to take a little while to open this. Okay, so here we go. This is just all the notes I'm going to be going. So definitions, theorems, things like that I write down. You don't need to worry about copying it all down because it's all here, all right? And then what else is in here? Formulas. This is the big one. Formulas you can have on the exam. So on all exams, you are allowed to have these files right here. So you need to open these, print them out, bring them to class. I'm not going to provide you these. You have to go do those. So make sure as soon as you can, go print these out. This first one right here, or this one here on the bottom, I think it's 6 pages of formulas. This thing's so slow. I'm just going to download it. It's always faster to download it. There we go. So there it is. Print that out, bring it to class. Yes?
Formula page without the watermark on there?
Don't. No, because it's copyrighted stuff. Yeah. But everyone has to use these, all right? You can't use your formulas from pre-cal or, you know, your favorite unit circle thing. Like, sorry, everyone's going to use the same formulas, and that you need to get like familiar with these, know what's on them, know what's not, right? So, questions on that? All right, I think I'm done. Yes?
Sorry, can we
No.
use that on the test?
Yes.
Okay.
Everything in that folder can be used on the test, but you need to bring it. If you don't bring it, it's on you. Yes?
Were we supposed to like review sections 1.1 and 1.2?
You don't have to.
Okay.
It's, if you want to, you can.
Okay.
Yeah, it's totally. We are not going to invest time in the class reviewing college algebra and pre-cal. We'll kind of fill the holes in as we go, because a lot of people, their math is like Swiss cheese, right? There's things that they're good and there's holes in places. So we'll try and fill it in as we go, you know. Everyone's going to have different weaknesses, so that's why it's so important for you to engage and ask questions and let me know when you don't understand something, right? Anything else? Yes?
We can't use notes on the test, like our notes like we take in class, or?
No. It's not a note. Yeah, the tests are not going to be open note tests. Mm-mm.
Can you use them on quizzes?
That will depend,
Okay.
right? So one of the things I say in the syllabus about homework is to bring your homework every day. Even if it's from like 3 weeks ago, I would bring all your homework every day. Because I might give you a quiz where I say you can use your notes, you can use your homework. And if you don't have it, well, that's on you, right? But tests, no, those will be straight up, you know, this in the formula sheets. Sometimes, don't hold me to this, I might use allow you to have a reference sheet, which is just like a single sheet of paper front and back. Formulas, steps, procedures, no worked out problems. That's, if I do anything, it would be that, but it's never just going to be open note. Yes?
So for quizzes, can I use my tablet and use all that stuff and everything?
As long as, well, if it's a quiz that I'm going to ask you to turn in right then I'm going to need a hard copy of it right then. So you'll have to do it on paper.
Oh, I meant like just accessing my homework and stuff, pulling it up, that stuff, you know, you said.
Oh, yeah, yes. Yeah, I know what you're saying. If I say it's an open note test and your notes are on the tablet, that's okay. I'll just keep an eye on you, make sure that's what you're doing. Yes?
Are quizzes going to be pop quizzes, or will we know in advance?
It could be either one. I might tell you we're going to have a quiz next class. You might walk in, I give you a quiz. Like,
So you could tell us in advance, could there be a pop quiz on those days too?
I seldom give a quiz on the material that we just covered on the same day.
Okay.
But sometimes I do, but it's never something where I'm like, ha ha ha, you don't get it, ha ha. It's always like, the quiz is constructive, you know? It's like, the idea is that, okay, we did this, let's see if you get it. If you don't, it's not like, I'm never gonna, if I gave you a quiz on material we just covered, it would either be a group quiz or it would be something where it was more of a participation quiz grade. Make sense? That's kind of cruel to just quiz you. Like, you get it? We'll see, you know? You always need to go and practice a little bit. Anything else?
So, just to be clear, the homework that we turn in, any homework that's after it's been turned in is fair game for quizzes? For pop quizzes?
Anything that we do, the next class we meet, you can be quizzed on that.
Okay.
Yeah. So there's always an expectation that whatever we do on that day, the next class we meet, you've gone and done the homework and had an opportunity to ask me questions. You're walking into the class and you have a pretty good understanding of things. Now, normally I start class with, are there any questions? You know, do you have any questions? Now, I can't spend 40 minutes answering questions, but I can, you know, knock out one or two, depending on how long the problems take. So, yeah, you need to know the material by the next time we meet.
And are the class recordings going to be posted on Canvas and YouTube as
Well,
well?
in Canvas will be the link to the YouTube. They'll be posted in YouTube, but the link will be in here. Mm-hmm. All right. So I can already tell that we're going to be behind, okay? Just because I said I don't want to talk for 40 minutes and I went for 44 minutes here. So it's okay. I'm not worried about it. There's some room in this class to be able to catch up. Let me think about how I want to do this next. What the next step I want to be here. I'm going to change the order. Let's talk about how to succeed. We've done the syllabus, right? Let's talk about how to succeed in Cal 1. All right? So I thought, a good way to maybe get to this idea of how to succeed in Cal 1 would be for me to, let's look at a problem here that everyone here should be comfortable with and familiar with, not have any issues with, and let's see how this goes, all right? So we're going to talk right now about taking the limit as x goes to -4 of something like x squared minus, let's go with 3x, let's go with plus 4. All right, so obviously when you're doing something like that, you're going to have to set up the proof, right? You're going to do, for every epsilon greater than 0, there must exist some delta greater than 0, such that when you're doing the limit, right? This is obviously you do this, right? You set up this proof that you establish what epsilon is and delta, and then you take the absolute value of x minus 4. You make sure that that's less than delta so that you can force that function x squared minus 3x, its absolute value, to be less than epsilon, right?
I'm hoping you're kidding.
I don't know what you're talking about.
Okay, good. That's what we need. Okay, that's what we need in this class. We need people who are going to be willing to stop me and say, I don't understand what you're doing, right? That is how you succeed in this class. If you sit there and let me come up here and do stuff without you knowing what I'm doing, which no one in here should know what I'm doing here, all right, then there's going to be a problem, right? You're just going to sit here and say, I'll go figure it out when I get home. Probably not, right? I'll just go watch a bunch of Khan Academy videos, right? So that's not what this is about, right? This is your opportunity to engage me in learning, right? Now, if it gets to a point where I'm being slowed down to the point that it's going to stop us from progressing through the course, then I'll kindly somehow deflect the question to, hey, let's get together, let's talk about this outside of class, after class, let's talk, you know what I mean? But you have to be willing to ask the question. That's one big way to succeed in this class, is to not have the pride or insecurity to ask, right? The other thing, so just ignore this. The other thing is most of my Cal 1 students are successful when they form groups outside of class. They study with somebody, they get together, someone's always going to bring strengths and weaknesses into the group, right? You're going to have someone who's like got that down, but maybe they don't get this, and maybe that's where you can help. Or maybe you're the one who knows it, and the people around you don't, and you can help them, and that helps you, right? So I can't force you to form groups, right? I can just encourage you to do that. That's kind of on you, right? I'll try my best to let you all work together in here on things so you at least get to know who your neighbor is. But ultimately, when we walk out of here, it's on you, right? Do y'all know what a Discord server is? Yeah? Okay. So my Cal 2 class, they stayed after and they talked about setting up a Discord server, and they're going to, so they're very motivated to group up outside of class. Again, I can't force you to do that, but you have a discussion board on our Canvas page. You can reach out to your classmates, say, hey, who has these times available? Whatever. I can help facilitate that however you want. If you want me to put together a poll, what times are you free, and get some data together, I can do that, whatever. Just you tell me what you want, all right? All right, so that's what I think. You've got to show up, all right? You've got to show up. It's Cal 1, right? So you got through pre-Cal, right? So you should be somewhat mature in terms of your like a student maturity. You know that you can't just like show up and pass the class. You also have to be willing to make a lot of mistakes in here, right? There's going to be a lot of times for you to make mistakes, and that's okay. Don't get discouraged. Part of this is, you know, do you have that fortitude to keep going, right? Instead of like just wilting away, right? So you know what? I'm going to keep going. I'm going to try this until it makes sense. Isn't math hard when it doesn't make sense? When it does, it's just like, oh, okay, I see that. How many of you have to take Cal 2? Oh, wow. How many of you don't have to take Cal 2? Don't? Really? 2. 2 people don't have to take Cal 2? I always teach this class like you're going to Cal 2. I've never said, oh, well, let's just act like you're not. Okay, so my job is to prepare you for Cal 2, which if you've talked to anybody, they've told you what about Cal 2? No? You haven't talked to anyone about Cal 2? Yeah? What else? No? Y'all haven't heard anything about Cal 2?
No.
I teach Cal 2, yeah? It's hard. Okay? Cal 2 students wish they were back in Cal 1. They wish they were, right? It's really hard. And I'm not saying that because I'm trying to intimidate you or scare you. I'm just saying that it is. I mean, it's like I'm not going to paint it to be something it's not, all right? But I guarantee you that if you struggle in this class and you come out of this with a C, you might be taking Cal 2 multiple times, okay? 3 times, 4 times. Your goal is to come out of here as an A/B Cal 1 student. Then you will at least be in position to do well in Cal 2. All right, you'll be in position. The only analogy I can make is that makes some sense is that in Cal 1 we're going to learn how to walk. We're going to learn how to walk forward, right? And in Cal 2 we're like doing moonwalk backwards. You know, like you have to have complete understanding of the mechanics of walking straight and forward before you can even talk about doing anything in the reverse. So everything we do in here in Cal 2 we do it backwards. It's much harder to go backwards. Going forward is like formulas, and it's very easy to follow formulas. Going back, there's no formulas. Okay, I'm getting ahead of myself. All right, yeah. What's calculus about? What's Cal 1 about? Y'all ready to get into this? All right, so I want to give you a real simple introduction into what this whole course is about. Like if I were to break it down into like one idea, and it's hard to break Cal 1 into one idea, but I'm going to try to do it, all right? So let me pick this screen up. Yeah, I've got to do one more thing. So my goal is to not use the projector on this front, to just use that screen, and I'm going to turn this off and just use the board like this. We'll see how that goes. All right, so let's see if you can recall this. All right, now I'm not messing with you anymore, all right? We're ready to get down to business. So see if you remember this. Can you find the equation of the line through 2 given points? I'm going to get to the point of calculus in a second. I'm going to build up to it, all right? So can you find the equation of the line that goes through 2 points? This would be a college algebra or pre-cal topic.
I know it's not pre-cal.
Pre-cal? You remember doing it in pre-cal?
I just did that.
You may have done some of this in pre-cal. If I give you 2 points, right? Let's say they are the points x1, y1, and another point x2, y2. Does this look familiar, everyone? If I give you 2 points, can you find me the equation of the line that goes through them? There's some formulas, right, to do this? Okay, so let's remind ourselves. Also, if I give you 2 distinct points, there's only one line, right? There's only one line through 2 distinct points. So we are trying to find the equation, right, of that line. So what's the equation of it? So we need a couple of things. But the most important thing we need, the most important thing is this formula called the point slope formula. We are going to beat the hell out of this formula this semester. Point slope formula. It's going to be all used up and, you know, dirty and fingerprints all over it because we're going to, all the time we're going to be using this formula, all right? The point slope formula. The point slope formula says this. It says if you're given a point and a slope, right? If you're given a point and a slope, which is why they call it the point slope formula, if you're given a point and slope, the equation of the line is y minus y1 equals m times x minus x1. That is the point slope formula for the equation of a line if you're given a point and a slope. Does that look familiar? Yes?
Could you also do y equals mx plus b?
That is the equation of a line, but it is not how you get the equation from a point and a slope. Right? So if I give you a point, sorry, if I give you 2 points, right, you can't go straight to y equals mx plus b. You can eventually get to it, but you can't do it right away. If I give you 2 points, you can't use this either yet. Okay? You can't use this. But if I give you, right, if you have a point and you have a slope, here's the equation of the line, right? This is it. So I've given you 2 points, haven't I? If I give you 2 points, how can we use this? Well, do we have a point?
Yes.
Have I given you a point? Yeah, I've given you 2, right? I've given you 2 points. But we need the slope. Remember m represented the slope of a line? M, rise over run? So we actually have a formula to get m if someone gives us 2 points. Does anyone remember what m is if you have 2 points?
y2 minus y1 over
Good.
x2 minus x1.
Recall, the slope of a line if you have 2 points is y2 minus y1 over x2 minus x1. I'm going to do, this is the very generic formula version. I'm going to do a specific example in a moment so we can actually see it with numbers. So let's just back up. If I have 2 points, there's definitely a line through those 2 points. I know how to get the equation of that line if somebody gives me a point and a slope. I only have 2 points there. I can get the slope by using this formula though. So once I use this formula, I will have a point and a slope and I can use this, right? So let's do this for a specific example. Example, find equation of line through, let's go with this. Let's go -4, 7, and 5. I'm not going to even think about whether or not this is going to be nice or not. I'm just going to make it up and see what happens. So I have 2 points there, yes? I would like to know what the equation, sorry, I'm lazy. Equation, right? The equation of the line is through those 2 points. So what I'll do first is I'll label the points. That way I can kind of use these formulas. I'm going to call this first point here the x1, y1, and this one the x2, y2, right? It is perfectly fine if you do it the other way around. You could do x1, y1, x2, y2. You could flip it, you'd get the same answer that I would get, all right? Which is actually kind of nice. So what should I get first? What should I work for? Let's get the slope, right? Let's get the slope. So what is the slope of this line? Well, it's y2 minus y1 over x2 minus x1. Okay, y2 is 16, right? Take away 7 over 5 minus, what? -4. Be careful with that minus -4, right? What's on top? 9. Bottom? 9. Ah, I didn't even try to make it nice and it worked out nice. 1. We have a slope of 1. Okay? Questions? All right, so I know the slope now, so I can come back over to this formula. I know the slope, right? The only other thing I need is a point. When I say point, I mean I need to know this, what x1 and y1 are. And I know that, right? So I'm ready. Boy, this is nice. I can use the whole board. Okay, so here's the equation, right? I'm ready for the equation now. It's going to be y minus y1 equals m times x minus x1. So I'm going to say y minus, what's y1? 7 equals m, the slope, which was 1, and then x minus x1, so x minus negative 4. Right? Let me clean this up a little bit. Y minus 7 equals, distribute the 1 through, this is a plus 4, so I should just get x plus 4. That is the equation of the line. Right? I'm going to go to a website called Desmos. Have you all heard of Desmos? It's my favorite two-dimensional graphing software, or not software, website. I'm going to just type this equation into Desmos on the left-hand side. Y minus 7 equals x plus 4. And it draws me a line, right? There it is. I'm also going to have Desmos plot me the 2 points. The points I had were negative 4, 7, and the other point was 516. But if you look at that, you can see that indeed we have found the equation of the line that passes through those 2 points. I know it's hard to see that from way over here. If there's ever a time where you can't make out enough to know what's going on, let me know. Okay? That's what we did. We found the equation of the line. Now, this is not in y equals mx plus b form, but it is still the equation of the line. So if you wanted to, you could make this look like y equals mx plus b by just solving for y. So I add 7 to both sides. I get x plus, what, 11? That's just a different form of the same line, right? This is we call this the slope-intercept form of the line because it's solved for y. Looks like y equals mx plus b. But this is still the equation of the same line. So in this class, I don't care what form you get it into. All right, got it? All right, we need that. Everyone needs to be absolutely 100% clear on this because we're gonna do this a lot. We're gonna have 2 points, or we're gonna have a point and a slope, and you're gonna be finding equations of lines. All right? It's gonna happen a lot. So now let's talk about the calculus. All right? So historically, obviously humans had to come up with calculus, right? So what was one of the motivating factors in why we needed to develop calculus? Let's imagine a trip that you take in your car, all right? Just to get this all going. You're going to start in your car, you get in your car, and let's say you're going to drive to Austin, all right? And what we're going to do is we're going to look at a graph of that trip. So I'm going to have here on the y-axis, let me put here, the big question, all right? The big question. What is the thing that kind of motivated calculus? Let's say this is time, and let's say it's measured in hours. And let's say that this is distance, and let's say that that's measured in miles. All right? So you get in your car, we're going to start the clock. You haven't gone anywhere yet, right? So in your car, start the clock. Time is 0. You've gone nowhere, right? So that point should be on the graph. Then you're going to start driving, right? You're going to speed up, slow down. You're going to start going towards Austin, yes? So what would happen is as time goes on, you're going to travel some distance. And, you know, whatever that looks like, you're going to wind up, let's say traffic takes you 2 hours, okay? And let's say it was, just to make things simple, 60 miles that you went, all right? Took you 2 hours to go 60 miles. Seems pretty accurate with I-35 traffic, right? Okay. So one question we could ask is what was your average speed on that trip, right? So what was your average speed or velocity. Speed and velocity are not the same thing, but we're not getting into that right now. All right, that's more of a physics question. What was your average speed / velocity? All right, so we would need a formula for velocity or speed. Who knows the formula to figure out speed? Go ahead. Distance over time. Okay, speed, I'm going to put V for velocity. Velocity is the distance you travel divided by what? Time. The time it took you to travel that distance. Right? That's your average speed. So you know what? I'm going to change something. This V, I'm going to call it V, but underneath I'm going to put okay? Average speed. I want you to understand, we're talking about the average speed here. So for this trip, could you tell me the average speed? Do you know the distance you traveled?
Yeah,
60 miles, right? Do you know how much time it took you to do that? 2 hours. So if I wanted to find the average speed, right, on this entire trip, it would be 60 miles, MI, divided by 2 hours, and 60 divided by 2 is obviously 30 miles per hour. I'm putting MPH instead of miles over hours. It means the same thing, right? Your average speed was 30 miles per hour. Now, does that mean that you were driving 30 miles per hour the whole time? No, you were speeding up, slowing down, whatever, right? Traffic, whatever. But average was 30. Geometrically though, this is the big thing. Geometrically, if I asked you to connect these 2 points with a straight line, like this, that's not very straight, but you get the idea, right? What is the slope of this line? What's the slope of it? Wasn't it rise over run? Okay, so what's your rise? What's your run? Isn't that the same computation? Okay, so the slope of this blue line actually is equivalent to your average speed. Yeah? So this right here is actually the slope of the line, right, connecting the 2 endpoints, connecting these 2 endpoints. We call a line like this that connects 2 endpoints on a graph, excuse me, we call this the slope of the secant line. The secant line. Don't worry about the name, okay? But that's what we call it. If you give me a graph and you give me 2 points on that graph and you connect them with the straight line, that's called the secant line, all right? So the speed on the whole trip is actually equivalent to the slope of the secant line connecting the 2 points. Nice connection, right? That's a nice connection to have. So this is not yet calculus, right? This is all stuff that you could have done in algebra. So now let me ask this. Let's go to 1 hour into the trip, okay? At 1 hour into the trip, I want you to look at